Hi roboticist, today we are going to finish the project of a pick and place in Gazebo. Last time what we did is to make this pick and place application in Gazebo with MoveIt as interface. So as a recap, if you go to the launch file of the cobot simulation package, I'm gonna put the link in the description down below of my repository. This will be the launch file, and then you just need to launch the file to check where were we. So here is where we have created an interface between Gazebo and MoveIt, where basically in Gazebo we are going to replicate what we are going to do in the pick and place here in MoveIt. And so in today's video what we're gonna do is to finish this project and replicate this scene, so 2 tables and 1 object that has to be picked and placed in a Gazebo. We are going to face a problem of picking, and that is very common in this kind of application, and we are going to figure it out how to solve it. Okay, so before to start, make sure to subscribe to the channel if you like this video, hit the notification bell to do not miss the next topic. And again, if you want to master your career in robotics software engineer, check the link in the description down below where you can enroll my course. So the first thing that we need to do is to create a model of the table and the object that has this dimension. So basically we are going to create table 1, which basically is going to be a box with this dimension, table 2 with the same dimension, and the object that has to be picked with this dimension. So the approach will be to create a model of these 3 objects, let's say, and put it into a Word and save the Word. So this is something that has been already done on behind the scene of this video, and you are going to find it in this my cobot repository. It's gonna be in model, and now we have the table that has to be picked and the object that has to be picked. But let's do it from scratch again. So open a new terminal and run Gazebo. I don't want to go too much into the detail of creating a Word. There's a more specific video to that, and also how to organize your package. I'm gonna put the link in the description down below. So basically what we need to do is to create a model editor. Then we are going to do here and basically we modified this box in order to be the table that we have designed in the C++ code. Okay, so this is our model that is gonna be the table. So what you need to do is to save as. So go into the folder that you have created. So it's gonna be called simulation. Cutting workspace, source. So you need to select the folder that where you want to save, and but it so you choose here, and then you type the name of your model that you want to save. I'm not going to do that because I already did. So I'm going to cancel it, and what I'm gonna do is to create a box that will be our object that has to be picked. Here we are. This is the object that needs to be picked. So again, you need to save this model and in the same folder, or in the same folder belonging to your package. You just need to save in another role, like picked object. I don't wanna save it because I already did, because I don't wanna make so much confusion in my folder. So basically we can exit the model editor. So here now what you need to do is to take the model that we have created, put a table here, second table here, and the object here. So let's do it, and let's go to insert. You're gonna see that in your model folder you will find the model that you have created. Okay, then we need to place the object that needs to be picked. Okay, let's play, and then you can see that the object stands on the table 1. Okay, this is the scene that we have created in our C++ code. Then what you need to do is to save the word as, then go into the folder, you need to save in the folder words, and then as you can see I have already saved this, so I'm not going to do that, but basically you need to select this folder and then create this file here. So now after that you have saved the model, you can exit. Okay, so what we need to do is to spawn in our launch file the word that we have just created. It's gonna be this one. Okay, this launch file was already created, so if you go to the launch file and you're gonna see the cobot bring up MoveIt scene. Basically it is the same launch file that we have created last time here, with the exception that I have put our Word file as an argument. This is the word that we have just created, and we have launched the Gazebo word in post, where we have put as the word name here. And basically it was really the same. We had to load as a Ros parameter robot description our chakra file, then we set up the position of the robots, we loaded our word inside the empty word, that this word contains itself the models of the table and the object. Then we need to spawn the robots, need to load the controller manager with the name of the controller that we have created in the configuration file, cobot join state and trajectory control yum file that is gonna be belonging to the same package, but it's here. So basically it's gonna be this one. And then basically the same, we need to spawn and then we need to launch the planning context, move group, and MoveIt Rviz, which basically were created last time with the MoveIt configuration setup. So let's try this and let's see what is going to happen. Here we go. We have our robot spawn in our world with our table here. Okay, so what we need to do now is to run the pick and place application. You will see that the object appears here, and here let's see what's happened. Is approaching, then is closing, and then we have a problem here in the picking. So it seems that something strange happened. So it seems that the grippers are trying to reach a certain position, but simply cannot do because the controllers are not designed for this application. So what happens is that last time we used only Rviz that use fake controllers, but now when we try to pick an object, something very weird is happening. So in your opinion, why is gonna be that? So let's close and let's see into detail what is happening. So this is our launch file that basically it's correct. And what we need to analyze is the controller, the trajectory control file, and the pick and place application in C++ that is gonna be here. Okay. So here you can see the problem here. When we close the gripper, we are sending a request to the gripper to close at this position. So basically, when we asking to close, when we calling this function close gripper, we are asking the gripper right and gripper left to go into this position. So to close the gripper. Plus minus 0.055 millimeters. But the clearance that is here is below of the total width of the object. So here the problem. So we have we are asking the gripper to go into a position that simply cannot do, because if he does, he needs to compress the object, and simply the gripper cannot reach that position. And in order to make it work, we had to set up the gripper controller of our robot as a joint trajectory controller and a position controller hardware interface. So I remember that this is the type of controller that you have from your software side, and the position controller are the type of controller that are based on your hardware interface. And since that Gazebo is quite a good replication of what is going to happen in the real world, we can see that if we set as an hardware interface a position controller, basically we cannot achieve that position. And then you can have this weird behavior. So how to solve that? What we need to do is to set an effort controllers as hardware interface for the gripper. And to do that, we need to modify, or better, to update our URDF file for our grippers, or better, our transmissions. So let's see into the detail what I have modified in order to make it work. Okay, so what I did is to create another cobot underscore mimic chakra file, which is the same file of cobot camera chakra that we have used in all these videos so far. Check it out to better understanding. So this is the file, and basically is the same structure of what we have used so far, with the difference that I have included this chakra file as a a macro, which is called a gripper mimic, and I call it as a macro in when I wanted to build our TCP. Okay, so let's go to the gripper mimic where the modification is done. And here the structure is the same as the one that we have used so far, which is called gripper chakra, with the difference that in the transmission tag of the gripper right and the gripper left, I have put a transmission effort macro. And where this tag has been created? Well, in the joint linking chakra file, which has been modified. Okay, so this is the macro from, as a recap, for the cylinder. This is the macro for the link box. This is a general macro for the joint. This is a transmission macro that expose, let's say, a position joint hardware interface. And what I did is to create another macro that I called transmission efforts, that exposes as another interface an effort joint interface. And this transmission design has been added to the transmission of our gripper. So basically these are the modifications that I made in order to make it work. So as a recap, since that it will be very important, the joint of the gripper left is gonna be is gonna be a mimic, and this is how we construct our Ros plugin as a mimic. And this is the Gazebo plugin that is really important in order to keep the object fixed once this has been picked from another link, in this case the gripper. Okay, so this is the first modification that I made. So since that I didn't want to make any confusion, what I did is to create another MoveIt configuration file, which I called cobot config. Don't worry, I'm gonna put the link in the description down below of my repository to check that. So in order to see what this package has been constructed, let's edit it with the help of the MoveIt setup assistant. Okay, so since that I don't want to modify nothing, I don't want to create a new one, I'm gonna to edit the existing one and then I'm not going to save. This is only for you to understand how I have created this cobot config MoveIt package. Nothing new. So this is the chakra file that I have. Here you are. This is our robot. Just made a self collision. The planning group, I set up an arm as a planning group based from the joint, from the base link to link 1 joint to the gripper joint, and then the hand is created by the links gripper left and gripper right. Then I set up the pose as last time, and the effector, I call it hand, which is has as parent link the gripper connector and the group name hand. So basically this end effector is composed only from these two grippers here. So passing joint, I don't have it. These are the controllers, but don't worry about that, we are going to modify it. Simulation, 3D perception, I put a point cloud, we are gonna use this in a later video. Information, configuration. Okay, so since that I don't want to save, you can generate the package, but in this case I just exit. So nothing is done. But let's go into the detail of how I have modified this package. So first of all, what I did is to modify the Ros controller YOM file belonging to the configuration folder of our cobot config package. So here we are. This is automatically generated. I decided to comment out. Well, we could use, but it's a mess in the namespace of your robot, and you risk if you use it that the controller manager doesn't recognize your controllers. So here I have set up as an action interface a follow joint interface of type of follow joint interface attributed to this joint here, and the same for the gripper controller, and both controller has the namespace cobot. Okay, from here nothing new from the last time. Then I created a cobot MoveIt controller manager, which is this one. Basically it's just a copy and paste of the last package, with the difference that I needed to update it. And okay, basically this is the MoveIt configuration file. So now the most interesting part is what I have modified to my cobot simulation package, and in particular to the configuration file of the controllers, YOM file, and the launch file. So I have created a launch file, which is this one, that spawned a a cobot mimic chakra file that I have created. Then we are gonna set up the Word file as we have set up before. And then for the controllers, I load the cobot join states and this one, mimic trajectory control underscore to yum file, and the rest is equal. So let's go in detail of what there's inside this Ros controller configuration file, which you find it here. So basically the ARM controller are the same, is of type position controller joint trajectory controller. So this joint has as another interface position controller, and it's gonna be okay because we didn't find any problem. But the modification is here. So I have the gripper controller, and then I have an effort controller joint trajectory controller, and effort controllers is because we have as a hardware interface effort controllers. Okay, and the joint that I need to put is the gripper right joint. And if I remember you that if you are going to use as a hardware interface an effort controller, you need to tune your PID value, proportional, derivative, and integer controller value. If you don't remember how to do that, I gonna put the link in the description down below. And last things is to check what's inside the pick and place gazebo, which has been modified, and basically this is pretty the same. This is the new position that our gripper needs to go, and if you don't modify the controllers as another interface effort controller, basically you are not going to reach this value. But since that now we have a effort interface as another interface, now you will do it, you will able to do. And basically it's the same, and what I have modified is the place position in the Z direction. I decided to put 0.1 meter upwards, and I'm gonna tell you why afterwards. Okay, so let's test it. Let's run our pick and place node in C++. Okay, the robot is approaching the object that has to be picked, and let's see what's happened by using as a hardware interface for the gripper and effort controllers. And now you can see that the object is correctly picked up. And then we go to the place position. We go at the target point, then we go down, we release, we open the gripper, and we retrieve. Here you are. This is a complete pick and place application with And here we are. This is a complete and functioning pick and place application simulated in Gazebo with Ros controller, position controller, joint trajectory controller for the joint from the base link to the gripper connector, and for the gripper you are gonna have a effort controllers, joint position controller as a controller for the gripper. And as you can see, this is why I have decided to put the place position in plus 0.1 compared to the other, because if you have paid attention, when you grasp, it slits a little bit of a certain point, and since that it will not peak at the center, if you don't modify the Z action, you risk that your object is gonna hit the table. You can try if you want, but I just propose you a solution for solve it. Okay, that's all for today. I hope that you enjoyed this video. If you like this video, make sure to subscribe to the channel, hit the notification bell, and if you want to master your career as a robotics software engineer, you can start from the beginning and check my Ros course for beginners. That will allow you to achieve an intermediate level. Again, thanks for your attention, and keep learning robotics with Ros.